I know there's not the exciting security talk in this slot. You've chosen to come here over the Internet of Hackable Things. That's a big decision. If that decision was not a decision you consciously made, and suddenly you need to see a magic show, the theatre is about, like, forever that way. So I won't be offended. Okay, the rest of you, there we go. See, there's always one. Every time. All right. Okay. Oh, wow, this has got animations. When you inherit decks from conferences, often they give you free gifts. Animations is apparently one of them. Okay, so hi, thank you for coming. My name is Laura. You can find me on the Twitters at lady_nerd. Please make sure you have the underscore if you do try and tweet me. The real lady nerd without the underscore gets a little cross. So please don't send her things about microservices. She doesn't care. I run a firm called SafeStack. That's not why I'm here. This isn't a sales pitch. But if you need to find me, we have a website on the internet, and I'm sure you could find it. We do agile security at the application level for companies in the US, in Europe, in Australia, and New Zealand. We've been running for about a year, and this is exactly what we do all day, every day. So this today is almost a way of me saving myself a few conversations along the time, because I'm hoping to put some of my brain into your brains. In fact, there's 2 of these talks this week. This is the first of the Modern Architecture Security series. Doesn't that sound posh? Right, the second one is tomorrow at 11:55, if you care to join me at the lovely Crown Plaza Hotel in a tiny room. We're talking about containerization security, so if you want to come along, please do come along, because the 2, microservices and containerization, do actually work closely together, and they can't be in the same talk. There's too much to cover. This slide is included for those people who are watching a video at home, because they are recording this. They're not recording me, they're recording the slides and my voice. All of the content for this talk was written in the last 3 to 4 weeks. It is relevant and it is accurate as the world is today. But today it is, by my watch, the 3rd of September. And by the time people reach this video in, say, December or next February, or whenever they find it, some of this will have changed. So if you reach this at another point or you reach back for it, remember, we are in a fast-paced architecture environment right now. We have to relearn our architecture skills pretty much monthly. So please bear in mind when you revisit this, it may go out of date. And that's not a problem. That's the way the world works. So in this talk, we're going to do a few things, and we're not going to do a few others. We are going to go over some fundamentals of microservices. This is not Microservices 101. I am not going to give you an Adrian Cockcroft-style demonstration of nanoservices that you can do on GitHub. Go and find Adrian Cockcroft's talks. He will give you the code and show you how to do this. It is also not Security 101. Like I said, you are here because you know you need to care. You are here because you know security is a thing and people will attack you. I'm not here to tell you why you need to care about that. I've assumed you already know that. So, like I said, not those things, but it is going to teach you some fundamentals about what we have as shared understanding of microservices. We're going to talk about prevention in the microservice space, which is stopping things from happening. Now, we can't guarantee all things will stop, but we're going to try our best to minimize them. And we're going to talk about detection, because the reality of security is we can't stop everything. And as architects, as developers, as ops people now, we have as much responsibility to actively defend and to monitor and detect as we do to prevent to begin with. So we're going to talk a little bit about the challenges of doing that in a microservice space. Right, so let's get on with those fundamentals. I'm super good in MS Paint. This is a monolith. This is where most of us have come from. This is a giant mass of code. It is probably closely coupled. It probably has all of those C words that if you go to Comania, you can see it talks about. I do recommend you check out Comania talks. They are awesome videos and they're all up online. This is what we're moving from. And it's a place where all of our code lives in one central place. All of our functionality, regardless of what it's trying to achieve, is in one central location. Our code base has probably evolved over time, and it's probably had a whole generational set of developers on it. It may have, if you're in an organization that's in the first 10 years of its life, been an MVP at some point in its life, as in the code that you wish would die a fiery death but hasn't. It's built your business. This is our monolith. This is where we're coming from. And this is where we're moving to. We are moving to a world where we understand that the functionality in our systems can be separate from each other, that we can componentize our architectures so that individual things can do one thing and one thing well. Now, this isn't new. Like I said, I'm not here to give you the background on microservices. This is a reinvention of service-oriented architectures from the last 10 years. There is a whole wealth of information about it. But the idea we need to keep in mind is we have split a monolith. We have taken something big and complex, and we have built something new and shiny. Now let's do a little survey to annoy the people in the room who are like, don't talk to me. How many of you are working on a fresh greenfield project that has no existing code and you're building microservices the first time round? Right, everyone else, please be jealous of the people with those hands. How many of you have a legacy code base that you're dealing with and you're trying to convert to microservices? Okay, yeah, that's more representative. Most of us have naturally, as part of our careers, reached a point now where we're working on an existing product. Very few of us get to write from scratch these days. We might get to write a new component, but the overall architecture probably is existing and standing. So we're looking at a transformation, not a complete engineering from scratch. So what are we trying to achieve with our microservices? Well, we're trying to create and deploy things fast, because speed is something that we now value quite closely in our organizations, the ability to adapt, to change our requirements rapidly, and to evolve as our customers are evolving, because they are evolving at speed. We want them to scale up automatically. We want to press button, get bacon. We want an amazing world that we've never had before. We do not want the complexities that we're used to. We want to be able to change things. How many of you have ever touched a code base and been told to make what seemed a simple change, and after 2 minutes of looking knew you were going to be there for a week? Yeah? Yeah, this is the problem set we're trying to address with microservices. We're trying to get rid of those days. Nobody wants to have to understand and pick away at a giant monolith to fix it. And as a security person, I am overjoyed this transition is happening, because it is impossible to understand the attack surface of a giant monolith. It is impossible to visualize the flow through the code base of a monolith, of saying, if I press this button here, what path does that take through my application? That's a really hard question, and it makes security really, really hard. We want to work in smaller teams. Many of you will have listened to talks by TradeMe and Xero and all of these big American companies that tell us about squads and guilds and pods, and there's a word for everyone. You know, you could probably invent your own. You know, we could have a murder of developers. Let's invent our own collective nouns. We want smaller teams. We want them to be autonomous. We want them to do big things. Now, here's a couple of things we need to keep in mind. My definition of microservices is not the same as yours. Your definition of microservices is not the same as the guy sitting next to you or the girl, if you're lucky enough. I know I see a few of you in the room. Hi. Ideally, a microservice should be single function. It should be very, very simple. A simple microservice in something like Flask in the Python world can be as simple as 5 lines of code. Teeny, teeny, tiny. Submit request, get back JSON, typically. Not all of us have been building our microservices in the same way, so let's admit for a second that maybe some of us haven't quite grasped the small microservices bit yet, the micro part of this, and that there may be microservices that live in your land that for various reasons end up 1,000 lines long. But let's make a promise to ourselves right here today, for a security point of view if nothing else. Please, if you reach a microservice that is 1,000 lines long, don't add a new line. This is not the time to add more code. There is refactoring in your future. Okay, you will notice that I mispronounce services from time to time. It's going to be horrible in the audio they're recording, but please forgive me. Right, so why are we caring about security? What are we going to try and achieve in these prevention steps? This should be teaching you to suck eggs, but you know, go Google it if it's not. Confidentiality. We want to keep things secret that are supposed to be secret. If I have permission to see one thing and one thing only, that should be all I am allowed to see. We want to maintain authorization and authentication, and if you don't know the difference between the two words, really, please go and read up. We want integrity. We want to know that the data we're storing is in the state we expect it to be. It's going to have changed from when somebody first gave it us, probably, but we need to know predictively what happened to it on its journey. How did it get to the state it's in now? And it needs to be available. And that's really important. So the things that we're caring about are this lot. Now, you'll notice if you're familiar with security terminology, this is basically the STRIDE framework from Microsoft. We're not here to learn that today, but these are the things we care about. We care if people are tampering. We care about if there's denial of service or people are getting more privileges than they should. So, without further ado, how do we prevent this? How do we stop this? How do we protect something that is infinitely fragmented? That we've got developers all over the place adding new microservices to an expanding little army of microservices. How do we do this? Well, it starts with how we decompose our services. Now, if you're in Greenfield, you don't have this problem yet, but you may be creating this problem for someone else. So still listen. Service decomposition is the process by which we take a monolith or an idea and we try and structure it down into its component parts for a microservice architecture. Okay? So it's turn big thing into many little things. And that's not as simple as just wielding an axe at intervals of 300 lines of code. I wish it was. We'd all have microservices by lunchtime. The size and complexity of our microservices is really, really crucial. So if you have something simple that's just 5 lines of code, one function, it says, I want you to tell me all the users in the system. And that's all this little tiny microservice does. It's relatively easy to understand the inputs and the outputs, right? Send one thing in, get one thing out. There's a fairly basic set of expectations there. That's really important from a security point of view, because when you're assessing your architectures, it's all about understanding the data flows through your system, understanding the connectivity between pieces. So, the size and complexity that you choose to make your microservices has a big effect on how easy it is to threat assess and understand the risks. Basically, the gist is, smaller and more contained they are, easier it is for you to enumerate all of the possible inputs and outputs and come up with your set of testing for it. Small microservices are easily automated for testing purposes. You can document them if that's your thing in a relatively minute fashion. These are easy to manage, not just as a developer, but as a security person. So make your life easier in both counts. Make them small and make them simple. You may have lots of them. I'm not saying you won't have lots of them, but just make them small and simple. One of the challenges of microservices is that our applications are actually really complex graphs underneath it all. So nodes and edges graphs, not like bar charts. And by that I mean, we have lots of different functions, and they all connect together. So one will call another, will call another. We have dependency chaining. In microservices, what we're taking is these giant monoliths used to have all these functions in the same place. So it was basically calling itself a lot. When you separate it out, suddenly you may have a lot of calls going between different components. And these different components might be stored in their own containers. They might be on a different physical hardware instance. They may be over an internet. They might actually leave your network and come back. There's nothing to say in a microservice environment your stuff has to be co-located on the same tin anymore. So when we're planning our microservices, we have to understand the dependencies between those services, because if we get this wrong, we end up with some really horrible side effects. Firstly, there's a few key services that are often shared, and that's stuff like access management, user permissions, roles authentication, that kind of thing. What happens when that crumbles to dust? Well, 2 things. It goes one way or the other. You either fail closed or you fail open. We hope you fail closed, which means your authentication layer has disappeared off the face of the internet. You don't know if this person is genuine anymore, so you stop. You say, I don't know what's going on. You show a pretty cat picture and you go, look, come back later. In a fail open situation, now everyone can see everything. It's Christmas. This is not ideal. This is how automatic doors work. They fail open because we don't want to be trapped in a building. This is not how your microservices system should fail. So look out for any components in your architectures that are highly dependent on each other, so items that are called more than anything else. It could be that you end up scaling that part a little bit more to be resilient, so having multiple of them across multiple zones, or you may separate that service. Just be mindful that if that service disappears, you may have cascading failures of other services. You also end up with fragility. You don't want any piece of your microservice architecture to be the bottleneck, the weak link. You want to make sure that every piece that is very, very vital, that's very important, such as authentication, is resilient in the fact that if that one instance over there disappeared, something else is picking up that load. And it needs to do it dynamically. You do not want to get a call at 2 in the morning saying, new microservice needed, quick, deploy, deploy, deploy. That should all be going on in your infrastructure, in your DevOps environment. I've made an assumption you're moving to DevOps too, because if you're in this space, that's pretty much the only way to play. If you're an organization that thinks they can do microservices or containerization without a DevOps way of working, come and talk to me afterwards, preferably, bring cookie or something, and we'll talk. Scaling and resource exhaustion is a big problem. Like I said, some of your components are going to be more vital than others. And as a result, we have to be very, very careful that those pieces are able to increase in load. The reality with our applications is we don't build them just to build them. We build them because we want people to do something. And if we do that job well, people do it more and more and more. So the load scales. At certain times of year in certain industries, things scale for reasons you didn't expect. For example, your company name gets in a magazine or on a news group on the internet, or you get linked from a Reddit post, which is basically for most organizations the same as somebody triggering a denial of service attack on a global scale. You need to make sure that your resources are scaling to your microservices so that you can deploy new instances as demand increases and dynamically scale them down again afterwards. You have to be able to factor in the scale down as well as the scale up. And the scale down needs to be automatic too. It needs to be automatic because of the way that we're hosting this. For many of us, we're in some sort of cloud-hosted environment or some kind of internal cloud-like environment where resource has a cost associated with it in terms of cycles on an AWS machine or in terms of internal resource where you're sharing infrastructure and you've only got a finite amount of it. So, we've decomposed our services. We're happy we have microservices. I'm not going into nanoservices or Lambda. Lambda scares the bejesus out of me. And maybe next year we'll talk about that and what that's going to do to this space. But today this is micro. What's next, however, is orchestration. We've got our services, but there are some parts that we can't decompose into microservices. And these are what we call the orchestration layer. This is things like your deployment mechanisms for your services. So what's going to roll them out? What's going to stand up new instances? It's how you share your secrets, because we should all know by now that hard-coding private keys in our code and passwords is probably not a great idea. So anyone who needs homework from that lesson, please feel free to take a note. We've introduced shared components like secret servers, like orchestration layers into our environments to compensate for this. And we can't have many instances. We can't have a secret server for every microservice. That's insane. And most of the time, these secret servers, especially if you're cloud deployed, could actually be outside of your control. You could be using something like Vault or a service by a third party that they're taking the responsibility for storing your secrets. You could be using a shared backup layer, so a backup or a log aggregation layer where everything is going out to one of these services. And the sad reality is, and what we don't like to admit, is attackers, we're kind of like engineers, but we're incredibly lazy. So if you've got 1,000 pieces in your infrastructure, in your architecture, and they're all doing their crazy microservice thing, and to get to our treasure, which is at the back of the system somewhere in a database, we'd have to pick through 20 microservices to get there. I'm going to be straight with you. I'm not attacking your application. I'm attacking your AWS account. I'm probably going to have a crack at your shared secrets vault as well if that's externally deployed. I'm going to go after whatever shared part is most accessible. Now, that could be a microservice you've written, or it could be a third-party component that you're using, or it could be part of your infrastructure layer that just naturally is exposed by the way you're using it. Attackers are like me. We are relatively lazy, simple creatures. So when we move to microservices, we make it more difficult to attack an application in full, and we encourage people to actually go after things that maybe we're not used to thinking about security of. And the danger is if one of these components is breached, such as a secret share of some description, then we've got some problems. How many of you use any kind of deployment engines like Octopus or Jenkins or any of the, okay. They're pretty juicy targets. I'm going to be straight with you. Many of them are now cloud hosted. I've used ShipIt through various projects now. We use Travis, the CI, continuous integration server, for many of my open source projects. These are big targets, and they've got interesting stuff in them. Not only do they have secrets that you want to steal, but they have often the ability to run commands on hosts. And if you can run a command on a host with a trusted account, that's awesome. That's giving me a backdoor. That's giving me a way to be there that looks legitimate in your logs. You're not going to get an alarm, an intruder alert, new account created, because your deployment account's doing all the hard work for me. So what do we want to do in this orchestration space? Well, we want to choose our technologies appropriately. Now, I'm not saying don't use cloud. In fact, I love cloud. Cloud is going to give us some amazing things. AWS, Azure, all of them have got very, very mature controls in place that, if you learn how to use them, can save you a lot of engineering effort. But you want to restrict access to these. I don't want to see an AWS or Azure account, or any of these shared secret accounts particularly, that is not using two-factor where possible. If you're not using two-factor on your orchestration layers, stop. Don't do anything else. Do not write another line of code. Go and put two-factor authentication in place. Go and restrict your accounts to the minimum access they need, and make sure that you've got some visibility on what access is going on there, what is happening. Monitor them. Configure them well. Out of the box, many of these tools are complex, and they have masses of menus you can go and play with, and little bells and whistles and levers and little... It's a nightmare in terms of actually understanding what you're doing. So please go and configure them well. And if you're not sure about the configuration, test it. If you think a control is stopping you doing something, go try and do that thing. Again, Microsoft and things may not like you going to do that. So I didn't, yeah. My lawyers are going to really not like me today. Challenge your assumptions with these. Secret servers particularly are a challenging area. Giving someone your crown jewels and saying, you look after that, you'll be grand, is really hard. And as a security person, it's something I personally struggle with. I use LastPass, but I use it in the knowledge that this is actually going fundamentally against my core of my being. My soul hurts. But there are benefits. We have to kind of be very conscious, challenge our assumptions, and go in there asking questions. We need to test regularly, test everything you're doing regularly, and test it with another set of your eyes that isn't your own. The next challenge has got to be the people, right? We've decomposed our services, we've split it into nice chunks, and we've got some orchestration around it to make sure we can deploy and we can scale up and down, and we share our secrets nicely. And then we've got all these pesky users that are kind of come and actually do stuff, which puts a massive spanner in the works, because it's like building a giant, big, strong wall and then putting an unlocked door in the middle of it. So let's have a little refresher. What we're talking about here is embracing the principle of least privilege, and that means giving your users as little access as possible. Now, there's two layers of users here, right? There's the users that you've built into your applications, the roles that you've given people, that you've defined in your code, but there's actually the users between your microservice components too. So components may talk to each other with service roles. So remember, each of those service roles needs the same role definition that a natural human being would. You need to consider them in the same way. They need as little permission as possible. Now, the ones that are particularly complex in this space are any agents that do monitoring, log aggregation, or backups, because they often get like the God set of permissions. Your backup agent can pretty much do anything on any host. So make sure you go over each of your roles and you define them carefully, and you understand what you can turn off. Take away permissions before you give them, and make sure that you review these permissions regularly, because service accounts particularly, we never go back and look at after we've first set them up. And microservice to microservice interactions, our users aren't going to be aware of them. They're not going to be the ones that tickets come in through the front end about. These are the ones we see in debug, or eventually when we're seeing a problem, but they're not going to be the ones that get as much love as the user-facing things. You need to be able to audit your user access. So AWS and Azure both have identity management frameworks. So do pretty much every hosting provider now. On top of your microservices, you need to build a layer of auditability. And that's complex because it breaks the premise that you should only do one thing in your app. Suddenly you've either got this monster of an auditing thing that everything needs to talk to, or everything just inherited a job that it didn't need to do for its core purpose. And that's hard, right? So find a way to audit it. I recommend that you use it like logging, and that you use your logging frameworks and just kind of, it's almost creating a different type of log entry, and kind of segregate your logs at the point where the logs are aggregated together. But that's going to be context dependent, so don't go to your organization now and go, that'll work for us, because seriously, you've got big complex places. Automate all of this, and more importantly, alert off them. Many organizations have lots and lots of logging, and if it comes into a nice ray gun dashboard, they're happy, but the rest of it, it's just kind of sat on a disk somewhere, and nobody's looking. Using a cloud platform in microservices can actually be really helpful. Like I said, not on any commission here. We personally inside SafeStack, we use Azure, AWS. We have internally hosted things on our own kit. We have a crazy combination. I work with clients that use pretty much every kind of hosting you can imagine, some that I wish didn't exist. Mature cloud platforms can really help in the identity and access management space because they've done the hard work for you. Do not invent your own if you can use a hosting provider that's going to do it for you. Keep your microservices focused on their job, and then don't write the stuff around it. Use the frameworks as they're provided. Right, immutable architectures. All of you are going, oh my God, I write code, or I'm an architect. Why are you talking about architecture so much with infrastructure? But that's because this is all intertwined. Microservices rely on the fact that we need to be able to segregate, and often segregation means containerization, or separation, or different hosts, and we need that flexibility. That's what we're aiming for. Immutable architecture is the idea that we can destroy our architecture or our hosts on demand and just build them again, gives us a whole range of benefits, particularly in the microservice space. Firstly, it makes them auditable. You can end up with very, very simple configurations. Now, let's imagine you took your microservices premises of simple single function and minimal possible viable container for it. Then why don't you translate this into your infrastructure layer? Don't give a microservice a giant, fully functioned VM with all the bells and whistles if it actually just needs a 4-line web server that's going to listen to a packet. Having immutable architectures that can stand up different types of hosts based on different service complexity is really, really useful. And you can script all this. And we're developers, we like scripting, so let's go do more of that. You might not be the right person to audit your choices, though. So how many of you do infrastructure? How many of you are infrastructure type people? Well, there's a few of you. How many of you are developers? Yep. Okay, so hi, developers. There's a handful of infrastructure people in this room. Historically, and I know this, I've sat on both sides of the fence, we have not played nicely together. Not so much at all. Infrastructure people have a different set of concerns, and often there's this feeling that, they're making decisions and trying to protect borders and actually get us up and stable, and then the developers come and basically throw rainbows over it and tell us that we need to poke holes in all our well-planned defenses. I've been guilty of both sides of this. You need to work closely with your infrastructure people if you are coding infrastructure as a kind of coded DevOps style thing, because they know stuff you don't know. They've learned the hard way about many things. Infrastructure people, you need to work with your developers a bit more because they're going to teach you how to save yourself a world of pain and basically automate yourself out of a job, which means you'll get to all of those cool things that you've actually wanted to do for the last 10 years of your existence. It also avoids configuration creep. Now, scope creep in microservices can be problematic. Like I said, you start with 5 lines of code, and before you know it, you've got a tiny monolith. You can have the same problem on your hosts. We add an exception here because, well, we were testing and we needed to test this thing, and then we add a new little service because we were experimenting with this library over here. How many of you have done an experiment on a library and then realized 2 years later you still had it somewhere in your environment? I have. You pick a library or a framework, you go, all right, I'm just going to do a proof of concept, blue sky idea thing, and yeah, next thing you know, you're doing like a bit of a review and you're like, what the hell is this? This hasn't been updated in 3 years, and it's still sat here in my production code base. Having a mutable architecture and a coded deployment for it means your microservices, you know what's on that box. It's only going to be the libraries and frameworks you've told to be there in your script. When you change your configurations or what your service needs, you change that script. You don't rejig it. You blast the box into orbit and you build a new one. It means you don't end up with this legacy of tangled dependencies that you're not sure you're using anymore. Now, if you want more on this, I really recommend you start looking into things like the 12-factor app. If you haven't already looked into that, that's a really good starting point for understanding the types of controls you can do to increase your ability to deploy, reduce risk, and make engineering easier in applications. The benefit of reducing configuration creep means that if an attacker does get into one of your microservice components, their changes are overwritten the minute you nuke that box. So if you're doing overnight rebuilds of your boxes to get new patches and things applied, your attacker has a finite window in which they can operate before their access disappears entirely. So use it as a kind of a keep clean mechanism. Flush out the rats in your system by just not having the boxes long enough for them to be able to do anything. And that's where Lambda is heading to with its on-demand service instantiation and then shutdown. It becomes really, really challenging for an attacker at this point. If you have got good architecture that is going up and down and is just not persisting, that's just really, really hard. And that brings us back to what we've mentioned earlier. They're going to attack something else. We've talked about the orchestration layer attacks, but we also need to talk a little bit about you lot. Because they're going to start attacking you. They're going to start attacking where you go and play. They're going to talk about your source code repositories. They're going to talk about any kind of shared service. So how many of you use Jira or another ticket management tool? Yeah? They're going to go after that. Some of you will be using it in a closed network and going, haha, I'm on a closed network. That's okay, they know that too. It's okay, most of you still connect to the internet and check your Facebook, so you're probably, it's not that much of a protection. If you can get onto an individual's host, if I can compromise one of the users of a system, then I'm going to do that. We've proven time and time again you can give somebody a very minute amount of money, like £100 in the UK, they'll give you any access you want. For a chocolate bar, you will give me your password. So, remember, immutable architectures are doing great things for us, but there's always a ripple. It always moves on somewhere else. I'm not going to give up. I don't like giving up. Attackers don't give up. We've got egos and things. We're just going to go somewhere else, and you lot are a lot easier, so... Here's some fancy words. I love fancy words like this. I don't say them out loud because I sound like the person who only learned a word by reading it, so I don't know what they actually sound like. But it means, I get all the toys. Okay, so monoliths as an architecture type tended to be homogeneous. We would go, we are a Java shop, and we will go forth with Java. Or we would say, we're PHP, we're a little bit more relaxed, but still PHP is just for us, and we can do all the things with PHP. And it doesn't matter what your language of choice was, there genuinely would have been a language in your environment. My first environment was COBOL, and we were COBOL for life. Microservices embraces the idea that you can use different technologies for different purposes because they're suited to different jobs. Different microservices could be written in different languages, and it doesn't matter because we define the interfaces between them, not what goes on inside. So we do a lot of pacts, so assuming that your contract between two components stays the same, it doesn't matter what's under the hood. And you can test all that stuff. But then we get a bit crazy. We get a bit kid in a candy store at this point and go, but that means I can do Node and Go and Rust and Erlang, and wouldn't it be fun? And people like me cry. Big tears at this point. Not because those languages aren't great. Those languages are all fantastic in their own way, and each of them suited to different jobs. Rust, for example, is changing the way that application security works in those type of installed applications because it gets rid of some classes of vulnerability. Node and Go are fantastic for very asynchronous projects. But the problem is, someone like me, but from another country, goes and stands on a stage at a conference somewhere fancy, probably in New York, where the proper people go and hang out. And they say, this week I did microservices in Go. And what happens? The Spotify effect. All of them, across the world, you see a ripple, like that Spotify engineering video. It comes out, and suddenly every organization that used to be a PHP shop or used to do .NET has decided Go is the only language for them. And they just leap into it. They don't look at that language in terms of what the problem is they're trying to solve and whether it is actually suitable. I've seen some abominations written in Node that should never have been written in Node. Any of you written in Node before? Okay, those of you who haven't, if you're a developer, don't go look it up. Go and try and write a for loop. Just go and do it. You'll learn. Education for all. And those of you who have done it will understand why that's a bit of a strange concept if you've come from traditional object-oriented languages or synchronous languages. Okay, so what I'm saying to you is choose the right tools for each microservice. So I want you to be free to choose different languages. That's really important. But I want you to choose the tools that are right for the job you are doing today, not what the internet told you in a video. That's really important because not all technologies are the same. Not all frameworks exist for all languages, even in the Python space, which is where I develop primarily. I write a lot of Django, but I've got a lot of clients who write in Flask, for example. Those two frameworks are fundamentally different with how much provision they give you, how much work they do for you in the security space. And if you went in assuming all frameworks had the same things, you would probably miss some of the work you need to do. Those of you coming from .NET land, if you move to things like Node or Go or any of these much smaller languages, you're going to be used to big framework libraries where you didn't have to go to the internet and find them, they were just built in somewhere. Now you're going to have to go out onto the internet and find plugin libraries or frameworks that help. And that's challenging. Because vulnerability management is really hard, and that's the idea that every technology comes with an obligation, much like getting a puppy. It's awesome, and you're like, I'm so excited, I got a new technology, and it's great, and I'm going to stroke it and feed it and whatnot. But you also have to clean up after it. It's going to poop on your carpet at least once a day. You're going to have to go and find the right toys to look after, where there are different frameworks and libraries. You're going to have to support this thing. Now, in a homogeneous environment, that's not too hard. It's still hard, you've still got a lot of work to do. I've got a client that's 4 people, and they've got 112 different technologies, and they're not microservice, they're monolith. You put it into a mixed environment where you've got many, many, many technologies, you don't have one poop on the carpet once a day. I don't need to take that analogy further. Vulnerability management at scale is really hard in heterogeneous environments. So if you are bringing in many languages, make sure at the same time as you have the discussion saying, yes, we're going to use it, it's going to save us time, that you factor in some mechanism for checking for vulnerability. So checking CVE details, checking the internet, checking Twitter, so that you know what has changed if there is a problem. That you have a mechanism for choosing libraries and frameworks wisely, that you have questions that you ask about each one. Now, that means you have to have the power to say no occasionally. And we, in SafeStack, we try and make no our most expensive word, the word we use as infrequently as possible. But you always have to be able to say no. And you have to have a clear reason why you've done it. So embrace all of the new technologies, but realize each one, much like a puppy, is a lot of work. And you don't have to look after it just the day you wrote your cool microservice. You're going to have to look after it for the rest of your existence. So please, do it wisely. One of the biggest problems we have in microservice environments from a defense point of view is plugging all of the vulnerabilities that not necessarily in the code you wrote, but they're in the libraries and frameworks you bought in to do it. So remember, your environment is an aggregation of the bugs you wrote, the bugs someone else wrote, and the bugs you don't even know exist yet. Okay? So then we need to test it. So we need continuous automated testing. I know many of us are on the testing journey, and the automation is coming if it's not already there. And I've had that conversation a million times with many angry testers who just want some love and support. So if any of you actually have the resource to help your testers and get them resourcing and training, please do that, because your testers are going to save you a lot of pain in this space. You need to get them testing things that they're not used to testing. They need to do pack testing, so that connection, that contract between microservices, you need to be testing that, because that's got security consequences. If that pact changes unexpectedly and you don't see it, it could be exposing extra functionality you're not aware of. There's a set of links here. I won't read them out. These are 3 tools you could go and use free of charge as of today that will bring you automated security testing in your environments. Now, OWASP ZAP is an attack proxy. It's actually an automated tool, a vulnerability scanner. You could do this on your microservices. You could do it across all of them. It's not a charge per play basis, which any of you have used things like Fortify and tried to get licensing across a microservice thing. You'll realize that you'd actually have to cry tears of gold to afford that. Gauntlet is a testing framework. It's designed, its tagline is do mean things to your code. I really like that. It's written by a guy in the US, and it's very, very good. You can get started. BDD is behavior-driven development security framework. So any of you use Cucumber or any of these languages where it goes, if I am so-and-so type of user, then, in that kind of human-readable language, it's that, but for security testing, which is pretty cool, right? You can use these things with Selenium, with the tools you're already using, and suddenly your microservices have got a whole layer of security testing without you paying a penny to an external pen test firm, which is a win for everyone involved. You can do fuzz testing. How many of you have ever done fuzz testing of your applications? Any of you know what fuzzing is? Oh, one of you. Hey, you're exciting. So fuzzing is something we don't normally see outside of reverse engineering fields in the security space. It's the idea that you stick giant amounts of unexpected data into your systems. So if you've got a file upload, for example, on a service, you stick a file it's not expecting. You corrupt bits in your file, and you do it in as many ways as humanly possible. There's a lot of exciting research that's using genetic algorithms to generate fuzz data. If you really geek out at data, this is really cool. But you could do this. You could do fuzz testing of your own file upload microservices, of any service that you think has got a potential for the input to be difficult to control. So, for example, high levels of free text fields, file uploads, file sharing, any kind of where the input is so difficult to define you can't just regex it. Think about fuzz testing. Think about load testing them. Because fuzz testing is like the strange cousin of load testing. Load testing being the idea you throw so much data at it, so much traffic, just to see at which point it's going to fall on its knees. Many organizations never get round to that bit, but as a security professional, that's what we do day to day. A denial of service is as good as a win if you can extort money. So, load testing is your basics to understanding, could you survive a denial of service? And in microservices, you need to be doing this against all external components that are exposed, not just your entry point, but any that are visible online. Even if you're not supposed to be able to query them and get good answers, you need to see how they cope with being queried without, the right permissions. What do they do if they receive a request they're not supposed to answer? What if they receive 10,000 of those? Fuzzing, load testing, really important. So let's very briefly talk about detection, because otherwise they kick me out and get really cross at me. Detection. This is the bit where all of us developers go, oh my god, I have to maintain something after I've written it. And I'm really sorry, but that is how the world is working now. And it starts with logging and monitoring. So we're all used to doing logging for functionality purposes. That's, log all the things. We know that. We stick it in Raygun. We put it in New Relic. Most of us own at least 3 New Relic t-shirts. I'm pretty sure that's their job in life, is to give us all clothing. We send our logs. That's what we do. But we're not sending all of them for a start. Make sure if you're using a microservice architecture where you have outsourced identity management to another component, for example, to your cloud service provider or to an orchestration piece, that you're logging there too and sending it to the same places. A lot of architectures, they focus their logging on the application components they wrote, but not necessarily the gaps that the infrastructure is taking up for them. You need to see your infrastructure logs and your application logs in the same place. And if you have security devices, also put those logs in the same place. There is no point at all of having a web application firewall if nobody is looking at the logs and tuning the results of it to work properly for your environment. So make sure all your logs are being stored. That's a good start. And make sure they're being stored in an aggregated central position. That place needs to be a special place. Now, if you're sending them to a third party, then choose your third party wisely. Ask them questions about penetration testing and how long they keep their data for and all of those things. But if you're storing it somewhere you control, it needs to be secure. It needs to be in a different account if you're storing it out in the cloud somewhere. Don't store it in the same AWS account that you store the rest of your app in, because the minute I compromise your hosts, I'm taking out your logs. I'm also taking out your backups if I can find them, so also probably you want to put those somewhere safe too. They want to be in a mutable format. Nobody, not anybody in this room, even if you consider yourself the most senior architect, senior administrator in your organization, nobody edits the logs. Nobody. If possible, put file integrity monitoring on your location and alert. If your log changes once it's been in long-term storage, you've got a problem. There is something going on. So go, alert on it, find these places and set them up to be immutable. They need to be away from your production environments too. That should be common sense, right? Yeah, definitely don't post them on the internet to a site that you've written. That's my other piece of advice. So poorly managed logs are really awesome for creating denial of service stacks too. So microservice logging is complex, right? Like our authentication piece, where we've got a piece that we're like, well, all of our pieces need to talk to this. How do we scale it? Well, logging is on all the pieces too, except for our logs are all going to one central location, and they're all traveling at the same time as other things going on. So you have a very fine balance between how much logging you can put through your system and the performance of everything else going on in your system. Be very, very careful that you test the worst case scenario for your logging, because there are certain circumstances where your application will deal very well with high demand. But high demand means high logging. High logging means high traffic, and your logging service, denial of service, is the rest of your microservices. Okay? So please test your environment for unexpected places denial of service comes from, and logging is often one of them, because we don't think about it. It's like taking out the trash. We just kind of do it. We don't think about the repercussion of the traffic on our network. And then we actually have to watch our logs, like really, for real, like all the time, all of you. Now, I say this knowing full well that in my last 12 months as a business, 83% of the customers I have worked with kept logs and had never looked at them. I had one client who kept logs for no more than 14 minutes. He had 14 minutes history of his application. Wonderful. Logging is the only line of defense that you can really trust if it's set up well. It is the only record you have of what happened in your system, because you're not seeing it from what the users see. You're not seeing what the attacker actually did. You're seeing the ripple effect of that on your system. You're seeing the measure of the after effects of someone clicking. So if you're not watching your logs, you can't see when things go strange. Don't rely on your alerting to work out of the box, because most of the time you need to understand what behaviors you need to alert on and set those alerts up. As a developer, I know this was a big transition for me, having to monitor logs and understand logs and do alerting and on-call, and oh my God, it was pain. But if a microservice means that each team can take a service and own it and build it and deploy, and they have that autonomy comes with the cost that they then have to monitor it too. So it's kind of the cost of playing if we are going to separate our architectures into tiny components. Wonderful, we are doing well on time. So let's wrap it all together. There was a lot to cover today. I could have given you the bells and whistles, look, I built a nano service or microservice demo, but like I said, Adrian Cockcroft, Sam Newman, who wrote the book on microservices literally, these are all great people. Go watch their videos and things. Today we talked about the fundamentals of microservices from a security perspective. I gave you all of the things that I would be looking for if I came into your organization today, you drew your microservices on a board, and we started to do threat assessment. These are the things that you have to do when you're defining your services. They are the things you need to look for. They're the things I need to see starting coming in as requirements. If you know your service needs to log X, Y, and Z, that should be in your acceptance criteria, because that feeds all the way through your flow. I need to see ownership of a microservice for the team that built it, so that they're logging and understanding that their service is an amazing little attack vector. And they need to understand all of the ways they can destroy their own stuff, but that somebody else is going to do it for them. You need to understand these shared components, because we're going to need more and more of them. And we need to understand how to configure them, how to keep on top of the configuration, and we need to understand how we choose them well. How do we trust the big marketing spiel that says, oh, we do the Securitons? That's not a good metric. We're engineers. We don't want marketing. We want to be able to prove things. So you want to be able to do measurement. You want to test things and do science. We talked about prevention. We talked about separating our services and decomposing. We talked about the orchestration layer. We talked about a number of different things you can go look at. And each of these slides, you can go and take these to your organizations and think about it in the terms of your architecture, because this is where this counts. This doesn't count for a microservices 101, I just showed you how to do it. That's why we're not looking at one today. This matters for those organizations who are transferring a big successful app with a giant customer base and separating it, that are working in a new way, but they actually have genuine risk going on and genuine complexity in their environments. We talked a little bit at the end about detection, and I really need to emphasize just one last time that the only front line we have for microservices is us as developers. There is no infrastructure team on the planet that is big enough to understand these new architectures and protect them dynamically. So as developers, we now own this space. This is where we live now. And that might mean some new skills for us. That might mean using tools we're not used to, and it definitely means that we need to approach this slightly differently, because in the good old days, we wrote code and it was ugly, and we sent it to someone else and they took care of our ugly baby. Now our ugly baby stays with us and is going to cause us trouble for the rest of its existence. So we may as well do it right and save ourselves some pain. I was really lazy. I'm supposed to tell you about all the other sessions I like. I only really like mine. So yeah, you should come to my other one tomorrow about containers. And by the way, that's not Docker 101, because really, you can just Google that. I will be around the place. I am on the Twitters. You can find me there. You can find me on email. You can find my company and find our website. You know, stalking is kind of legitimate business practice now. More slides that Microsoft maybe put in. Yay. Okay, I get in trouble for this every year, so we'll continue a tradition. Please, can you give me at least a 6 on the feedback form? Okay, thank you very much. If you have any questions, we do have 5 minutes remaining.